Hello, this is the video that's going to go over the 2016 AP Statistics number 3 question. I'm trying to make sure this is in the picture frame okay here. It looks a little strange. Okay, so this question starts off by saying that it talks about Alzheimer's disease and how it's a cognitive ability that is typical of aging, but it takes people beyond what you expect for cognitive ability, as you would expect for aging. So, a local newspaper published this. A study finds strong association between smoking and Alzheimer's. And the article reports that they tracked the medical histories of 21,123 men and women for 23 years. It also says that people who smoke 2 packs of cigarettes a day or more, the risk of developing Alzheimer's disease was 2.5 or more times the risk of those who did not smoke. So, first question says identify the explanatory and response variables in the study. Like, first, I'm trying to make sure is this an experiment or is it an observational study, or which is what they asked that down here. So, like when I'm looking at this, I'm thinking, what's going on? What's going on? So they just track some histories of people. They didn't force them to do anything. And what we're trying to relate are how much, what you're smoking a day, how much you smoke a day, and whether you get Alzheimer's or not, right? If you're susceptible to that. So the explanatory variable is the one that's the what's causing things, right? Or what's affecting things. So that would be how many cigarettes you smoke a day. This says you have to have at least 2 packs. So explanatory variable is how much you smoke, right? If you smoke 2 packs or not, or more a day or not. And the response variables, well, then what happens? Well, whether you have signs of Alzheimer's or not, right? So smoking for the explanatory and Alzheimer's for the response. Pretty short and easy. You don't have to talk too much about that. Part B is the study described in the article an observational study or an experiment. An experiment has to be set up where everything is controlled except for one thing, and then you randomly assign treatments. And that's a really big thing with experiments. You got to put in your head that if you're doing an experiment, you're the one that's randomly assigning treatments to the patients. They do not get to choose, and you can't just observe it, which is the case here. They're tracking these people, but they never told them you have to smoke and you don't smoke, right? We're not going to make people smoke and tell other people who want to smoke, tell them they can't, right? That's not our job in the world. So we would never do that. So this could never be an experiment because we're never going to make people smoke, right? And so it's just an observational study. We're just observing what people do normally anyway, and then looking for some kind of correlation with that or some association with that, I should say. So since it's not an experiment, I will never, ever be able to prove causation. I won't be able to do it. I'm not controlling everything, and I'm not randomly assigning treatments. So an observational study, sure, you can do a scatter plot, you can do proportions, and you can do things, but you're never going to be able to show causation. You're only going to be able to show an association, which is fine, but it's not as good as an experiment. Okay, so you would just describe that. You say this is an observational study, mostly because they did not randomly assign treatments. The treatments were observed and the results were observed. Part C, exercise status, regular weekly exercise versus no weekly exercise, was mentioned in the article as a possible confounding variable. Explain how exercise status could be confounding in the study. Well, it goes back to this. If it was an experiment, we would have controlled how much people exercised, and we would have blocked them and said, okay, we want all the people who exercise in this block, and we want all the people who don't exercise in this other block. And then we're going to make some people in the exercise group smoke and some not smoke. And then some people in the non-exercise group, some of them will smoke and some won't smoke. And we're just going to control everything, and we're going to randomly assign everything. But of course, we can't do that in this situation because it's smoking, and we're not going to force people to smoke, and we're just observing. So when you're not doing an experiment, and you're not controlling everything, you will get lurking variables. There's other things that you're not controlling that could be showing up in your results, right? So that's what's going on here. Exercise could be a lurking variable in this observational study, because the more a person exercises really could be a factor in whether, in their brain function and their health of their brain, and whether they are susceptible to getting Alzheimer's or not. So that's why it could be a lurking variable. And this exercise was never controlled in an experiment. So it's can show up as a lurking variable along with other things as well. Yeah, and that's all. You just have to describe that it wasn't controlled, so it could be lurking variable. It could affect what we're seeing, right? Along with the amount you smoke. We don't know which one of these is really causing things, but when we look at them one by one, like if we were to do exercise and look at that graph, or look at smoking and look at that graph, we can get an idea of an association, but we'll never be able to show causation. So be careful. I'll show you what the scoring guide had to say. You can pause the video and just kind of read through that at your leisure. Whoops, I gotta go up a little more. At your leisure, so you can see what they had to say. All right, thank you very much.